Now we move on to the Pic Status Register. Like all microprocessors, the PIC has a flag register to indicate arithmetic conditions such as the carry bit. The flag register of the PIC is called the status register. We'll be discussing the various bits of this register and provide some examples of how it is altered. The status register is an 8-bit register. It's also referred to as a flag register. Although the status register is 8 bits wide, only 5 of the bits are used by the PIC 18. The 3 unused bits are unimplemented and read as 0. The 5 flags are called conditional flags, meaning that they indicate some conditions that result after an instruction is executed. These 5 flags are the carry, the digital carry, the 0, the overflow, and the negative. Okay, so you can see here D7, D6, D5 all X'd out because they're not used. And then as we go from least to most, the carry, digital carry, 0, overflow, and negative bits. So we'll take a look at each one of these individually and give a brief explanation of the flag bits of the status register and the impact that the instructions have on the registers as we go through them. The first is the carry flag. This flag is set whenever there's a carry from the D7 bit. This flag is affected after an 8-bit addition or subtraction. We'll see later how this is used. The next, the digital carry. If there's a carry from D3 to D4 during an add or a subtraction operation, this bit is set. Otherwise, it's cleared. This flag bit is used by instructions that perform binary coded decimal (BCD) arithmetic. In some microprocessors, it's called the AC flag or the auxiliary carry flag. The next one, the 0 flag. The 0 flag reflects the result of an arithmetic or logic operation. If the result is 0, then z equals 1. Therefore, a z equal to 0 is if the result is not 0. We'll see later how the z flag is used for looping. The overflow flag. This flag is set whenever the result of a signed number operation is too large, causing the high order bit to overflow into the sign bit. In general, the carry flag is used to detect errors in unsigned arithmetic operations, while the overflow flag is used to detect errors in signed arithmetic operations. The overflow and the end flag bits are used for signed number arithmetic operations are discussed later. And finally, the N or negative flag. Binary representation of signed numbers uses D7 as the sign bit. The negative flag reflects the result of an arithmetic operation. If the D7 bit of the result is 0, then N is set to 0 and the result is positive. If the D7 bit is 1, then N is equal to 1 and the result is negative. The negative and overflow flag bits are used for the signed number arithmetic operations.